Mics for everybody. Right.
Right is Joe. Stage right.
Yep, I'm right.
Okay, hello. All right, I'm Bill Venners. I've been using Scala for a long time, almost 10 years. And over 10 years. I've lost count. So I do consulting and training and books. I do Scala test and a lot of functional programming, and I have a lot of fun.
I'm Julie Pitt, and I've been actively working in Scala for about 5 years, but I've been fascinated by it for about 10 years. And there's a little bit of a gap there when I took a job at Netflix and kept diving into Java for a while. So my Scala enjoyment was a little bit delayed, but I've had fun since then.
My name is Stu O'Connor. I've been doing Scala for about 5 years. I got really interested in functional programming actually in college, which was unspeakably long ago. But and back then I thought it was this really cool thing. And I was like, I'm going to go do this when I get out in the world. And then it was like, no one's actually doing that. But I was thrilled that around 6 years ago, a good friend of mine said, remember that cool stuff we were doing? You got to check out this language, Scala. And I've been hooked ever since. Yeah.
I'm Mike Colquist. I work at Comcast. I've been doing Scala since 2009 or so. We were doing big Java apps. I also, by the way, really got hooked on FP in college, standard ML specifically, and then went into Java, Hibernate, and JPA, and all that for a very long time. Yeah. But then I started having fun. I started doing Scala, and here today to talk to you about it.
I'm John DeGoes, and I'm actually...
Right.
I'm John DeGoes, and I'm actually a CTO, so I don't need to code. But I do code nights and weekends. Why? Because I love functional programming. That's how much I love it. And I've started 2 companies based on functional programming, and it's just totally changed the way I think about writing software. And if I could, I would be writing code full-time, 100% FP, but I have all this other stuff that I do to pay the bills.
All right. Thanks, guys. Okay, so the format of this, I've got a few questions that I thought up this afternoon. You can tell I'm really well prepared. These are just meant to be kind of talking points. If you have a question you want to bring up, I thought about like some kind of elaborate scheme where you tweeted it and stuff, and then I thought, no, we're all in the room. Just stick your hand up and yell it out, and we'll handle it that way. So, okay, so I've got my first kickoff question, a very difficult one. Do you have fun functional programming?
Yes.
Anyone else care to comment?
Yes.
Yes. Yes.
Yeah, I think I just told you that.
Okay. Thanks for coming, everybody. I think we've established the. Let's jump in. All right. So a slightly more complicated one to warm things up. Then, what do you think is fun about it?
So I'll take that one. I think one of the fun things about functional programming is that it helps me actually understand software. And before I discovered functional programming, I basically gave up on software development because I was working on 3 million line of code Java applications where every object refers to every object in the entire system indirectly through some number of levels of hierarchy. And it's impossible to understand that. And then functional programming comes along and it says, look, you can divide your entire program into functions. And these functions, given some input, will return the same output. And so your entire program becomes defined by equations. And this way of thinking about your software, or understanding your software, is often called equational reasoning because you can understand the meaning of any part of your program. A equals B, and you know what that means simply by substituting a B anytime you see an A. And that changes the way that you think about software just tremendously. You know the meaning of things, and you look at the types and they tell you something about what your program is doing. And that's very profound, and it changes software engineering from this monstrously complex thing where you can't understand what's going on to something where you can break it down into subproblems and you can understand the subproblems. And by understanding the subproblems, you can understand the whole.
So I think my answer to that question would be, why is functional programming fun? And would be that it's not that functional programming's fun necessarily, it's that programming's fun. Like, I'm a programmer not because I can earn a lot of money at it. I'm a programmer because it's really fun to solve problems. Like, that's what I want to do, is I like working out problems. The thing that makes functional programming especially fun is that more so than imperative or other styles of programming, it lets me concentrate more on the fun parts. So instead of trying to track state in my head, which is something that's going to come up over and over again, it lets me concentrate on just the piece that gives me business value. Something I'd say that I think of a lot is how I came into not just doing Scala, but doing a lot of very kind of, deep down pure FP, was that when I got into Scala, I was in the Scala IRC room, and I noticed people talking about Scala Z all the time. I joined the Scala Z room, and suddenly I was somewhere I really like to be, which is in a room full of people that are smarter than me, which means I'm going to be on this learning curve, which again is fun. But one thing that stuck out to me is that the things that they were talking about, the things that they were abstracting over, were not things like a visitor pattern. They weren't things like, all these gang of four patterns that we're supposed to have learned. But instead, they were talking about things that seemed very fundamental to me, like how do we iterate, or how do we do loops, or how do we add things together, right? And this to me sounded very odd. It was like, aren't these solved problems? And it turns out that they are solved problems, and they're solved a lot better using these techniques in FP, and that they're solved in a way where if I use the stuff from Scala Z or from CATS or one of these libraries, I can kind of say, look, they've got looping and iterating and that kind of stuff down to the point where they've written real mathematical proofs to say your stuff's going to work. And so, again, what this does for me is it allows me to say all this stuff. I don't have to worry about a while loop where I've got something I got to keep in track what I got to set up before the while loop. I got to keep track of my exit condition, making sure that my loop makes progress. If there's somewhere I got to exit the loop, trying to keep all that stuff in our head. And it's something you're going to hear people like us say, and I think it's kind of an arrogant and kind of a jerky thing to say, is I'm not smart enough anymore to do Python, which I think is a little bit of a slight on Python, but it's the point we're trying to make is, this gets stuff out of my way so I can just focus on the fun problem I'm actually trying to solve.
So I'm going to answer the question with a double negative, which is the moment that I learned that not functional programming was not fun. How many of you guys come from Java? Okay. And how many of you guys have read Effective Java? Okay. Not everybody. So at my workplace, it was like 10 years ago, we were all about Effective Java, right? Book written by Josh Block that had basically a bunch of patterns for really just writing Java code in a pretty sort of fluent and standard way that just kind of made sense. And so my team there, we all kind of read this book, and we went through all the different patterns, and we talked about applying it, and we were like really fired up about this. And one of the topics that we would be discussing often was which of the three closures proposals was going to make it into Java, right? There were kind of these three main ones. And like a couple months later, I happened to go to a talk at my workplace by James Gosling. And I somehow miraculously managed to sit next to him at lunch, and I said, hey, what's the news? Which closure proposal is going to make it in? And he kind of was just like, it's like, hey, this is kind of a hard thing, and we might not get closures into Java anytime soon. And when I put that together with, hey, in Effective Java, in order to write a immutable class, it requires like this sort of 50 lines of boilerplate, or like in order to do sort of a lazily initialized singleton, you have to do this weird double locking pattern. I see some people laughing over here, like you guys know what I'm talking about, like exactly what I'm talking about. And so at the same time, I was listening to this interesting podcast called The Java Posse, and and so this guy named Dick Wall was talking about Scala and like how fun it is. So kind of comparing those two worlds, I'm like, oh, this sounds cool. So I got more and more excited about it. So that's kind of going back to that, it kind of made me realize, wow, what are all the things that I'm no longer like thinking about or worrying about that I used to have to worry about? And I think that kind of makes it fun for me.
I'll be really short. Is this on? All right. I'll say something. Say something. Hello. All right, good. I really like tinkering with things. I like making things work. I had fun doing imperative programming. I really like doing like autonomous robotics and poking stuff into registers and playing at that level. Doing functional programming, I feel like my tinkering, the things that I learn, the things that I come up with, are sort of more fundamentally true, right? When I'm tinkering with like Hibernate to try to get some query optimized, like that knowledge is lost at that moment, right? Like, whereas with I'm learning like cats or something, I'm finding like deeper meaning and deeper truths about category theory or about whatever it may be that I'm looking at. So I really like that. I really feel like I'm exploring this like new territory. There's all these smart people that have already sort of like laid this groundwork, and I can sort of pick it up. It's not sort of this ad hoc like technology evaluation.
Yeah, I think I just wouldn't add too much to all these things. That's I think programming is fun. It's fun because it's creative and it is practical. It's utilitarian. So it's like designing software is kind of like designing buildings. You can make them aesthetically pleasing or beautiful even, but people can use them for practical things. And I think it's just very rewarding. And functional programming, I think when I first came to Scala, it wasn't just attraction of functional programming. It was a lot of maybe some of the things that Java didn't have. I liked the static typing, but it was much more concise. So it was more than just the functional aspect of Scala that attracted me.
So I'm going to invoke a little bit of moderator's privilege here. I now want to move into what isn't fun about functional programming, a more difficult question. And I'm going to lob one out there that I've seen just because I don't want it to be lost here. So we have a wonderful panel of experienced Scala developers. Bill and I know, have the privilege of teaching newcomers to Scala. And it gives us a perspective on functional programming that it's very hard for people to pick up in the first place. That's one of the things that is difficult about it. And unfortunately, when you've immersed yourself in functional programming for a while, that's the way you think. And it becomes hard to remember how you used to think before you discovered it. So I think that's one of my that's not so fun parts, is that initial learning curve is tricky and it's hard to get people. It's very rewarding as a trainer to get people over that, but I think it's very frustrating as a newcomer. So is there anything else you want to throw out there? It can be anything related to functional programming or the communities and social groups and, I don't know, everything to do with functional programming.
The world is not immutable.
That is a very good one.
I don't know what else to say about that.
Yeah, I'll get the conversation going. So what I've seen in the wild is that there are some organizations that adopt the Scala Z Cats style of FP, which you guys like to call FP, which is and that works there when you have a leader on top, and they kind of make sure everyone comes up to speed and goes in kind of the same direction. So I have seen real world examples where that works. I've also seen places that do a functional. They like to use immutability, but they don't really have category theory front and center in their app. It's more domain specific kind of things where they talk about lists and seeks and sets and that kind of stuff. And then there'll be one person who loves that other style, and that I've seen not work so well. So I think that's a kind of a pain point.
Actually, the logical conclusion of that tends to be, I've noticed, that person gets frustrated that nobody else is picking it up and leaves this pile of code that nobody else knows what to do with. So
that's what I thought would be interesting to talk about, that, because that's, well, it's not the elephant in the room, but that's...
It's a tricky one.
Yeah, no, and I would say like 98% of functional programming is that set of immutability and sets and just being disciplined about it. Every time you run into one of these cases, you get so much further just by saying, like, I'm going to be disciplined about FP, I'm going to stick with mutability, I'm going to look at, ways to improve composition. And if you do that, like all those other things you can sort of grow into with time. I would say like one of the difficult things about FP is to sort of like take a breath and one, don't get overwhelmed by all of the new concepts, but two, don't let frustrations mount that like the industry isn't, adopting these things as fast as you might think they should, right? I think the FP is making great strides all throughout all languages, all platforms right now. Things take a very long time, to change a whole industry. And I think that's actually a success. It's not something people should be frustrated by.
So I think fundamentally, functional programming is actually quite simple. It's programming with functions. And a function has a domain and a codomain. And these are the types, the input and the output type. And every time you pass something a function, it needs to return something in the codomain. If it doesn't, if it throws an exception, it's not a function anymore. And also, functions, they always return the same output for the same input, so they're deterministic. And then functions, they don't have side effects. Their only effect is computing their output value. So that's all that functional programming is. There's nothing more to it than that. That's it. So if you're doing that, you're already doing functional programming. And then the rest of this stuff, the reason why we have libraries like Scala Z and CATS, and the reason why you're going to hear things like functor and other things in category theory are just because when you start programming using functions, you wonder how to do some things. Like it's a different way of programming. It's kind of a remarkable fact that you can build any program in the world using nothing but the functions that I just described. And then it turns out that you're going to run into problems when you do things like that way. Yes, it has all these benefits to reasoning and modularity and testability and so forth, but you're going to run into problems. And fortunately, these problems have already been solved. Like these problems have been solved by mathematicians. And that's category theory. That's where all these abstractions come from. And they really are basically the building blocks for how you solve the more advanced problems when you're building entire applications in this style. But it's important to remember that functional programming itself is very simple, and all you need to do to get started functional programming is writing these things that I've just defined as functions. And then when you hit problems, just know there's stuff out there, and you don't have to learn all at once. And there's plenty of people like me who will like drag you along and spend hours of time explaining because we want to grow the fold. Like we want you to understand these things, and we didn't understand them one day. And we know you're going to understand them someday if you just persevere and give us an opportunity to help you down this path. So take it one step at a time, and like never fear these weird sounding abstractions, because if you haven't felt the pain, then you probably don't need to learn them just yet. Like use these pure functions, try to build your software using this style. And then when you run into those pains, ask for help. But there's plenty of people around who are willing to help you out.
Can you help me, John?
Yes.
Okay, so I mean, my perspective on this is that I have kind of realized at times, well, I need a sophisticated, type system for whatever. At the time, shapeless was kind of the go-to. And I kind of realized, hey, I needed some kind of fluidity to my types for this particular application. And I tried to apply this kind of advanced thing, but what I ended up with was a pretty complex mess. And I ended up going back to the basics, right? Very simple data structures, basic functions, and that actually worked. So, what I struggle with is making something that sort of can use these advanced, powerful concepts, but is also very accessible and simple.
So, I agree with what you're saying, and I think it touches on a little bit of what you're saying, in that one thing I would think that is something that breeds some of the not fun of functional programming is, so we know we're better than everyone else, and we're doing everything the better way, and we tend to get full of ourselves, right? Programming and software engineering tends to breed egos, and it's a real problem in our industry. And I would say that we have a particularly acute problem with functional programming breeding egos, where you can get this sense of, oh my God, I'm doing it the better way, and everyone else who's not doing it my way is a problem. And this is, there's clear problems that have come up in not just our industry, our niche in the industry, our little sub-niches of our sub-niche. And I think it's something that we need to check ourselves on from time to time. I've been humbled recently, as I, up until very recently, was working at Verizon. We're trying to do massive, massive cloud deployments, and we're trying to do it entirely with, pure Scala. Then me and my cohort, Tim, over here at some point started, as you do, as you get into infrastructure and you get into big stuff, you start playing with Go code because it's just how they're doing stuff, right? And you're like, this is terrible, and you're like, this is terrible. But then you can't, it's hard not to then realize, you say, okay, why is everyone doing this? They're actually kicking butt and they're actually doing a lot of stuff. They're getting stuff done faster than we're getting stuff done, right? You look at what HashiCorp is doing with Nomad and Console and Vault and all these things, and they're cranking stuff out and they're getting stuff done. And it's something, and I've been humbled a little bit by that, where I always thought like everyone should be doing it my way. And being, I've probably been a jerk to people about that before, but there's, we're not the only game in town. And, although we definitely are doing it the better way, we need to remember that, not to let our egos get in the way of getting stuff done sometimes.
If I can pounce on this just for a second, this is the community feel-good hippie side of me. When you talk to people, try and remember when you were learning. And don't lose touch with that person you were 5 or 10 years ago when you were struggling to understand it. It's really easy to be impatient with people when they're asking a lot of questions, but you were that person at one point, right? And another thing I can recommend, having just spent the last month or so working with scientists learning R, it's really good to immerse yourself in something that you're a complete beginner on again, to remind yourself what it's like to be a complete beginner on something, just to, you get good at this stuff and then you lose touch with that. So anyway, you go ahead, Bill.
Well, I have a question. I had a question, but that's maybe your job. But the question is, so here's...
as the moderator, I bestow my moderator powers upon you.
Yeah, the question I had is like, when you were talking about the better way to do a loop, one of the ideas of having a while loop in Scala is at the low level, if I need to make it faster, I can do that. I was just curious to what extent, how often is that too slow? Is FP too slow? That's my question.
For me?
Well, any of you are using, the answer is traverse, I think.
The answer is always traverse. Yeah.
After a great deal of analysis, about 3.2% of the time, functional code is too slow, so you go and rewrite it. Yeah. No, that was completely made up. In case you didn't get that, okay. I'm quite good at deadpan.
Right. So I do think. Is this on?
I don't know.
Yeah. I do think functional programming can be too slow sometimes. I mean, there could be lots of heap allocations, immutable data structures, monad transformers, stacks and stacks of binds on binds on binds, causing massive heap churn and slowing the performance of your application down and so forth. And you do eventually run into these types of problems. But that said, there are reasonably fast ways to do almost everything in pure functional programming. And there are techniques you can use and libraries you can use that are really, really fast. And one of the trade-offs that you're going to have to carefully consider is sort of, okay, functional programming does give you strong types and composability and modularity, deterministic functions that are easier to test and so forth. Some techniques in functional programming can even guarantee resource safety. So you can make sure you're not leaking threads and leaking memory and so forth. And these things have lots of obvious value to the business. So sometimes it's a matter of trading off between some things that functional programming is very good at giving you, and then some things that in Scala on the JVM, functional programming maybe has to struggle a bit more with, including such things as performance and type inference and so forth. And there are definitely some drawbacks that come with trying to do pure functional programming in Scala and on the JVM. There's just no denying that. In my opinion, for the majority of business applications that I work on, I find that the benefits outweigh the costs, but we should be realistic about that and not deny the existence of costs. There are real costs to these things. It's just that for most of the applications that I've worked on or helped people work on, the benefits far outweigh those costs.
So has anybody taken a peek inside the Scala collections library, the implementation? Because that's not a functional implementation. I would say, it's like, do what makes sense for the situation, right? Even Martin Odersky would tell you that it's okay to use var, right? It's okay to be mutable in the right context. So I think in terms of
there's some dissension in the front row. It's all right. I'm going to cover crowd control here.
Oh my God, should I worry about the tomatoes coming here? No, I mean, but seriously, I mean, it is a multi-paradigm language. I mean, obviously this is about functional programming, but there is cause for marrying these techniques, and I think that really is a best of both worlds kind of thing.
I do think we should expect things to constantly get better with respect to performance too. We were kind of on the forefront of things, but now, now Java's got lambdas, right? So maybe now our megamorphic apply cost goes away, and maybe lambdas get fast again. Now that Java has like inspiration to fix this for themselves, they'll fix it for us too. So I think that this will also happen as we, as Java becomes more functional, they're going to deal with more garbage and figure out ways to, reuse stack frames or reuse, and so I think tail call elimination will come to Java eventually. Java 13, Java 14, something like that.
Yeah.
Yeah, and another thing is like there's very good techniques in functional programming for hiding low-level parts of a mutable algorithm behind a pure interface. So you can use those vars, you can use those dirty implementation techniques underneath the hood, and that saves the rest of your team members from ever having to touch that stuff, and still lets you reason about your code in this composable fashion, in this equational fashion. Because as long as the interface is totally pure, it doesn't really matter what happens underneath the covers.
I'm happy to take a question from the crowd. Otherwise, I have some more I can throw out there. But yes, okay, go ahead. What's missing for good FP in Scala? I'm repeating it because they always ask you to do that.
Stack safety.
Oh yeah, okay. Anything?
Cost of stack safety is insane.
We need better debugging tools. How many people here have said, all right, let's see what's going on. Got a stack trace. It's free.apply, free.run, flee.apply, free.run, flee.apply, and then it runs out of a thread pool. Thanks. And it, stack traces become kind of useless. And so, people say, what do you do? And I'm like, I don't know. What you do is you hope that someone comes up with like a different paradigm for how we debug our programs or how we, report errors and stuff like that.
Print line. I think it's very loose. It's Scala is its strength is you can call anything Java library, but that means that we still have null and we can still get null print exception. That means it's not easy to track when I'm doing I/O, and I can just use a var. I can use a val. I can use a mutable object. I can use an immutable object. They look the same. So what I feel like is, it's great to be able to do those things. And if you can't call into Java some way, then nobody's going to have used it in the first place. But I feel like it'd be nice if there was some way to partition or contain or, put things in their place so that you can say, hey, I want you to tell me if I accidentally do something with a mutable object and I don't know it or something like that.
I got it. We should have a naughty keyword. And you put everything in there in a naughty keyword.
I mean, it's kind of like the blessing and the curse of Scala, right? Like, it's the great thing about Scala is that it's not Haskell, and I don't have to talk to you about an I/O monad before we do hello world, right? What I can do instead is say, all right, Java? Cool. Leave off the semicolons if you want, and then we'll talk about the while loop tomorrow, right? But then like a year later, you're like, all right, now how do I turn all the while loops off? Because you've had your time, and now you got to stop having access to that stuff. So, it is a bit of a trade-off.
I think from like a day-to-day perspective, I think what would make functional programming on Scala a lot better is better support, or rather higher performance for megamorphic function calls, which are pervasive in Scala programs, and they impose significant runtime performance cost. And also heap churn is massive in Scala, functional Scala programs. And the GC is not very good at dealing with this kind of constant pressure on the heap. And I think the other thing that would help enormously in just sort of usability, developer aesthetics usability, would be better type inference, much better type inference, especially of higher kinded types, because the amount of type annotations you have to supply in cases can just make Scala code look even more verbose and even more ugly than it already is.
Since we're going through our wish list, I'd really like a collection library that doesn't throw, like just across the board, I think that would make more of a difference to me than like half of the abstractions I use. In big teams, that is. Doesn't throw.
Throw exceptions.
Yeah.
Like
So I don't
head.
want get on option. I don't want head. I don't want, yeah.
Any others? Because I can think of one more that hasn't come up yet.
Well, you can.
And I
you
find
can
it
talk too.
significant. Well, no, I find it significant that it hasn't come up yet. So,
Haskell syntax.
not exactly what I had in mind. No, one of the things that always seemed to come up was tooling. IDEs in particular, people would complain that the IDE support was lacking. I believe it's got a lot better. I'm not sure it's perfect yet, but it didn't come up in this group, and yeah, I think
Text
it has
editor
improved.
here, because
Well,
none of
sure.
the IDEs can actually compile the code that I write.
Oh, okay. Not even Enzyme?
Well, yeah. It's
Okay.
I would like a language server with integration with, VS Code or Atom or something. That'd be great.
Enzyme has one.
Yeah. Enzyme won't work for you?
I would like a,
Okay.
I would like a language server.
Okay. There was at least one more hand. Yes.
I will need to ask one of the mics for the questions, please. Thank you.
You can share mine. Yes, there was a question.
Yeah, we'll bring the mic to the question.
Okay. You have mine.
A lot of you guys talked about learning functional programming aspect, and I'm just curious whether for the new generation of programmers, whether functional programming as the first language learning would be appropriate. Will the ego eventually get in the way of learning the other way? I mean, not a single soul in here probably started functional programming before they started imperative programming. So if you can touch that aspect.
I'd be interested, did anybody learn functional programming first here? No? I have talked to people that out of the box learned Lisp as their first language, for example. So I certainly didn't. I was BASIC, the first one I learned. But yeah, I've talked to people who learned Lisp first.
So yeah, I think that I think everyone's first programming language should be a functional programming language. Ideally, that would be their last programming language paradigm. And actually, I started teaching my daughter functional programming when she was 7. And she gets it because the concept of a function is pretty simple, right? You stick one thing in one side and out comes something else. And and that always works. And it's very deterministic. That's all that you need to teach functional programming. So I've actually talked to a number of people whose first programming language was functional programming. And then they had to go out in industry and get a job. And then they didn't understand Python. It was just so confusing, or whatever program, Java. I mean, try to teach someone Scala and object orientation and inheritance and variance and all these things. It's just so complex compared to teaching them functions and data. So I think that we would do a great service, I think, to all software engineers if their first programming language that we ever taught them was functional programming.
So which language?
He's going to say Haskell.
Of course. If you give me the mic, Haskell, without a doubt.
We're speechless.
I'm sorry for my traitorous nonsense here up here on the Scala panel.
Yeah, Scala there's a lot going on in Scala. So,
that's true. Yeah, the only thing that Scala has over Haskell is jobs. There are plenty of jobs. And they pay well.
Nothing bad.
Math? I mean, that's really the first functional language, isn't it? I mean, you could do functional programming on a piece of paper, right? So I think it's actually a good place to start for sure. And making that kind of leap to, oh, you could actually put that into a computer and it would do something interesting. I think that's a really interesting way to think about it. That's actually kind of where I came from. I was actually, going to school in applied mathematics, and I just came to computer science just because I had to take an elective. And then I kind of realized, oh, I can make the thing do stuff. That's kind of cool. So here I am.
Any other questions from the audience here? Otherwise, I'll check what I had in my list of potentials. Oh, yeah, okay.
All right, so on the last one, that's something that I've thought about quite a bit, I guess. And like, I feel like functional programming at its core is just simpler. And so I feel like it's how you should teach people. But where I get tripped up is like one of the first programs that you want to write is something that prints hello world, right? And as soon as you start talking about monadic IO, like that is one thing that I just legitimately seem just like a higher learning barrier. And I don't know, do you just think that's inherently a higher learning barrier that people are going to have to get over if functional programming is first, or what?
I think that we're going to need to be careful about how we frame things, right? I made that comment earlier. The world is not immutable, right? The world has side effects. So in my mind, like functional programming is kind of like this idealistic fairyland in a way, because it's this world in which, you know, you have these kind of no side effects happening. So I think we do have to be realistic about the fact that at some point the rubber needs to meet the road. And so we have to be explicit about here's the boundary where everything is kind of nice and pure. And outside of that boundary, we have things having side effects. So I think that that concept is something we'd have to introduce pretty early on, right? Even with just hello world. So maybe you would start with side effects and move on to, you know, how would we do monadic IO, right?
Can we just ignore printline as a side effect and just say? I mean, really. I mean, you know, would it be terrible if the first functional programming language was Lisp? You know, where you don't have any types, you have one type, and you are side affecting, but you're at least programming with function-like things. I don't know. You know.
So here's what I would say. Here's what I would say. Put strline is a function that takes a string and returns an IO of unit, which is a description of a program that prints a line of string to the console. Put strline is nothing more than a pure function. And that pure function just returns a value, an immutable value. And that immutable value is nothing more than a description of a program. And then the runtime system for that program, the main function, if you will, is going to look at that value and it's going to say, oh, look, this is an instruction to print a line of output to the console, so I'm going to do that. So here I've explained in 30 seconds what put strline is, and I didn't use the word monad, I just used a function.
You just
and
did.
That's really all it is. So I would say, you know, we can teach them that, and maybe we don't have to use monad, we don't have to get into it right away, but we can teach someone that because I just taught everyone in the room that in 30 seconds. It's not that hard. It's like nothing more than a function that takes a string and returns a value, which is an immutable value that describes an instruction of a program.
Yeah, I'll be real quick. Monads aren't at the end of history, and there are still other possibilities. So, for example, I'll give you an example that Martin has talked about is using an implicit permission to do an IO. That way, if you don't have that, if you try to do something that has a side effect, then it wouldn't compile. But that would be, you wouldn't have to, it isn't a monad. You would have to, it'd be something in the background also that you wouldn't talk about, which would be an implicit, but yeah.
The best thing we could do is delete the mutable parts from Scala and just make it more like Haskell.
Just ignore hello world as like the introductory thing in programming languages because it's the dumbest thing ever.
Actually,
well, so Tim stole my question, but I think that hello world is a stupid place to start teaching programming. It's kind of an artifact of the compiled program world where nothing happened until you had an entire program and got to run it. And these days where you actually have, you know, an evaluation loop and you can print. You can
the REPLs, yeah.
Yeah, you can type stuff at the console, you know, teach, you know, iterating over a list, actually do some math, compute something, and then eventually talk about sort of these artifacts of like saving stuff of I/O and saving stuff to a file or sending it to a console or something is a weird concept anyway, and you have to understand what a computer is, which is really different than actually programming. So if we're going to teach programming, we should just leave most of that stuff out for a long while until folks understand the concepts.
Hey, how come I didn't get applause for my monads at the end of history comment?
You suggested implicits.
Question over here.
Anyone? Oh, yep, okay.
So the number of programmers in the world is increasing at a certain rate. Is the number of functional programmers in the world increasing at the same rate, more or less? Same question for Scala programmers. And what does that mean for the community?
I have absolutely no idea.
Yeah.
Does anybody know?
It means we're always going to be the 1%.
So I can't speak to that like definitively because this requires research that I haven't done. But
I'll Google it.
You Google that, yes. Good luck. But what I can say is, like, I attend probably like 3 or 4 conferences a year, and I've done that for quite some time. And what I've seen is that at the Scala conferences, 5 years ago, there was no FP content at any Scala conference. It was just like Akka and stuff like that. And these days, you go to a Scala conference, and it's 50% functional programming. You're getting talks on adjunctions and category theories and functors and like lots of zippers and lenses and this and that. And that's just really amazing to see that happening. And also the functional programming talks are generally tend to be the more popular ones. So you can see something's happening. And like meetups, like I've just seen so many meetups start taking off covering functional programming. And we have functional programming meetups in almost every city and sometimes specialized for different languages. So what we're seeing is a lot of grassroots effort. A lot of people blog about this type of stuff. A lot of people do videos. There are many more books coming into play. It really does feel like there's this bottom-up movement by programmers, developers who've just fallen in love with this and want to share it and talk about it and find ways to use it at their work.
So the authority on all of these things, Google, first of all tells me that functional programming languages are doing quite well, but then the very next one says that the fastest growing language is Python. So there you go. Google once again produces somewhat conflicting results.
I think you'd also find that JavaScript is, if you look at the trend of JavaScript, it's on a crazy upward trend. So I would guess that, perhaps not. However, what I would say is that FP does seem to be leaking a bit into all the other disciplines, right? Yeah. I'm now in a shop which is doing no Scala. They're doing Java. There's some closure around. But when I got there, a big effort that had just happened was to move their Java code into pure functions and use immutability. They're not using Scala Z and Traverse and all that stuff, but they know that there's a big benefit to purity and to immutability. And then what I'm surprised about is I'm like, all right, let me talk a little category theory, you guys. All right, there's this thing called a monoid, and they're like, oh, we actually all know what that is. And I wouldn't have expected that in a Java shop, 2 years ago. But so I do think that, and another thing that's happening is that, Scala is becoming very popular, right? And it used to be that you'd had a lot of people, if you hung out in maybe a Scala help channel, we start to see a big influx of people who, and it used to be Akka, right? It used to be the thing that you're like, I heard this cool thing, I want to try it out. It's a different paradigm, and it attracted people. But then very quickly it became Spark, right? Spark is a huge driver to Scala. That's why I would say more than 50% of the people who decide I want to learn Scala now are learning it because they want to learn Spark. I think that what's going to end up happening is, if we can attract more people to Scala, they're naturally going to get indoctrinated a bit by FP if they all of a sudden are in this language where all of this stuff is enabled. So I think we have a good shot at it. But yeah, JavaScript and Python are killing us.
I think it's worth taking the half step back because I've seen this interest in Scala from Spark, and the vector into it actually seems to be it's a lot of data scientists and a lot of mathematicians. They're used to Python. Spark has a Python API. They start using it through that. They decide Python's not fast enough, and then they see, there's a Scala Spark that everybody says runs faster, and that tends to be the vector that sucks people in. I didn't really have much more of a point than that, other than I feel the need to defend Python's honor a little bit in light of the.
So, if I may make a wild conjecture about Python's popularity, there's been a lot of movement over the last couple of years, just getting people that haven't been developers into being developers, right? Meetups, boot camps, all these kind of things. And Python is probably, and or JavaScript, the most popular language to use. So if I had to extrapolate, I'd probably say that it may be the fastest growing because there's actually new folks coming in, which is good, right? Which speaks to your point. The question is, are they going to continue on and go to Scala? Because so far we haven't been the go-to language for starting. Because as we took that poll earlier, like 0 people had started with Scala.
Yeah. And so why is Python in JavaScript? Why are these things becoming so popular and so popular with the non-programmers? Is got to be low barrier to entry, right? Like, imagine when you're like, cool, you want to do some big calculation, so let's talk SPT, and whereas with, and maybe it's a terrible story with Node, but you get up and running faster. With Python, you just type Python and you just start doing stuff. And that can be true for Scala, but then you'll have someone say, well, you should never download Scala yourself. You should have the SPT download it for you. So we do have some problems there, to which, specifically on barrier to entry, I think.
One more thing to add, NumPy. Yeah. Python has NumPy. Scala does not have anything that competes with NumPy.
Yeah, I was just going to say that I saw functional features going into a lot of languages, and so it's coming in that way into mainstream life, programming, but it's not taking over in that. For example, Kotlin, I've looked at that a little bit, it has a lot of things that seem similar to, just by coincidence, similar to Scala. But it doesn't have any immutable data structures. They're mutable. It probably will get that eventually, perhaps. But it's basically, has a different philosophy. And I was invited to the speaker dinner of their first conference. And so I wore my Scala, shirt to kind of, freak people out. And they really didn't like Scala. And they really liked mutability. So I think there's different things going on. It's not all going towards functional.
Any other? I have a couple more. Oh, yep, okay.
Is this the lack of libraries that really the reason that Python is so popular? Because right now there was a talk today on deep learning for Java where they had a replacement for NumPy of some kind. Not sure how ready it is. Do you think that Scala community will step up, or is it something that you don't see happening?
I think, I'm sorry, I shouldn't do this as moderator, but I'm going to say it really quick. I think this is something I'd like to see. It's one of those things that as open source developers, when you say that, somebody will inevitably turn around and say, why don't you do that then? And there is a good point there. But so that one of the reasons that the data scientists and myself were using R and RStudio is it solves a particular problem much better than we can in Scala right now. And that is taking basically a buttload of numeric data, reading it into some kind of table, doing some kind of very fast statistical manipulation on it, and plotting some stuff out. None of those things are impossible in Scala. They are all much faster to do in RStudio, much faster. And it would be great to see something that does that in Scala and get all that power.
Now, when you say faster, you mean faster for less developer time. You don't mean less CPU time, right? Because I think Scala does have very sophisticated numerical libraries available. There are lots of them out there, but it's not. But again, I think it's that barrier to entry is that we can do all the same things they can do. We can do them just as fast as they can do, but we need more developers.
This performance I would measure in CSV to plotted graph time.
Yeah, so one of the things I think personally where I've seen the most benefit from functional programming, because it helps us decompose programs into smaller pieces and reason about them incrementally. One of the biggest benefits I've seen is it helps you maintain code over time at a reasonable cost. You can change things more quickly and more safely in a functional program than you can in any type of mutable program. And that's very useful when you're building something that's long-lived and has to be maintained for a while. But if you're building some throwaway code, write once code, honestly, the maintainability benefits don't matter all that much. So I would not be surprised to see if there aren't large sections that don't end up migrating to functional programming or to Scala or even to static typing, because when you're writing something, it's a one-off. You just need to understand it that one time. You never even need to look at it again. You just want to go from CSV to plotted chart, then it's not necessarily important to be able to understand whatever you wrote because you're never going to look at it again.
So I've been working on an application that requires doing a lot of math, and what I've been using Scala for is prototyping and specifically doing type-safe math. And that's actually really saved my butt a lot of times, avoided a lot of bugs. However, once the prototype is done, then you go, well, how does this actually scale? I've looked at Breeze, for example, and it's mutable. And so you start to wonder, well, how do you make this work on GPUs? And maybe Scala doesn't actually make sense for all applications. It's not necessarily a silver bullet.
We're talking ourselves out of this, aren't we? Just kidding.
I can finish up with, is functional programming still fun at the end of this? Yeah.
No, Vlad had a question.
Well, just to continue this, so apparently like there was affirmation like functional programming could be like your first and last language, and apparently probably this is not the case, like and this example, and who is going to write like kernels, like I'm going to write, and so on. So probably definitely some usages where you probably cannot just use functional programming yet. Maybe.
I don't know. I've not that this is entirely related, but when you were speaking about that, I was reminded of the 25 or 30 year plan, or the thing that's been planned for 25 or 30 years, which was the Lisp Os, which never seems to have materialized. But it's this mythical beast that people talk about. We're going to have an operating system written entirely in Lisp at some point. So.
Well, I've used one.
It's called Emacs.
Yeah, the Symbolics machine, right? By an Emacs. Yeah.
So I think that there's just an enormous number of problems with software today at every single layer of the stack, and security vulnerabilities and people being able to hack into systems and just all this kind of crap. And it comes because we write slop code that no one can understand, not even the people who wrote it. And we don't have formal ways to reason about our software. And all of this comes back to the fact that we're not using statically typed functional programming. And in my opinion, that's the best tool we have today for writing correct software. And there are so many applications where we can take these techniques and use them to write things that are provably correct and have lower defects. So I actually think that the lower level things which are critically important to get right have a greater probability of migrating towards functional programming techniques, because I think they've shown the most inclination to solving the problems around security and performance. Like, that's somewhat a solved problem. Maybe not in Scala. Scala wasn't designed to do pure functional programming language, and it has to run on the JVM, so it has some drawbacks there. But there are low-level, purely functional programming languages that are very, very performant and allow you to do lots of very powerful things. And actually, there are whole kernels written in functional programming languages that have been verified.
I think Vlad had a question. Yeah.
Hi. So several years ago, Bjarne Strostrup was in Palo Alto, and when asked about the fact that now that they have monads in C++, are the C++ guys willing to adopt more like facts of life and that FP is like getting introduced? And Bjarne said, I don't know why functional programming failed. So any comments from you?
It's not dead yet. Thank you. So I'm going to be the optimistic one and say that I don't think it failed. I think we're seeing it more and more and more in all disciplines. If you're writing JavaScript in 2017, you're doing more functional programming than we did in C# in 2005, right? We're seeing FP get adopted everywhere. I think it's really important that we don't like sort of define this all or nothing definition of FP, that if you're not like purely typed static or Haskell, then you don't count. I think it's permeating everything we do, and I'm really excited to see like the research that comes out of that and what other ideas like Martin's capability-based idea comes out as a result.
Yeah, it's not really failed in my opinion. It's just a slow starter. Like, how long did it take programming languages to get lambdas? That took ages, from the time when they were invented to the time when modern programming languages just started shipping with them. But you know, there's hope for the future. Like Michael says, like, these things are changing and people are embracing these techniques and they're migrating into the front end. React and all these things are inspired by Spark is inspired by functional programming. You see really good ideas from FP leaking into all these programming languages and libraries, whether on the front end or the back end. And it's a sign that there's motion in this direction because functional programming does solve real problems that programmers run into on a daily basis.
So going back to what Vlad was asking about whether or not something like C++ would adopt, continue to adopt these type of things, the obvious joke answer is that C++ will adopt just about anything. It's the kitchen sink of programming languages.
So I think this is probably wrapping up time, right? I'm looking around to see whether I should be or shouldn't be. We could go on. Yeah, I'm getting the nod that we should start wrapping this up. I'm sure everybody wants to go home or to the pub or some other place anyway. So just thank you all for joining me up here. Thank you all for coming. I guess the final question would be, are you still having fun with functional programming?
Hell yeah.
Yes.
Yes. Yes.
Yes.
Yes.